tangent lines. All right, a tangent line for a circle is a line in the same plane as the circle, but it intersects the circle in exactly one point. So before we had chords, right, a chord intersected the circle in 2 points. Well, a tangent line intersects in exactly 1 point, and we call that the point of tangency. So basically, for each point on the circle, there's one tangent line that can be drawn. So this blue line that I have drawn is the only tangent line that can be drawn through that point, because it can only intersect the circle in 1 point. So for example, let's say I wanted to put point of tangency down here. My line would have to come something like this. It would have to intersect it in exactly 1 point. So it doesn't really actually go through the circle. It just barely nicks it at 1 point. Well, we can have common tangents. So if I'm given a couple circles now, any line, ray, or segment that is tangent in 2 circles in the same plane we call common tangents. So the first part of your assignment, you're going to draw in common tangents. So if I look at my first situation right here with these black circles, let's see if I can draw in a common tangent. Well, I think the tops and the bottoms I can kind of connect. If I drew a line like that, right, that would be tangent to both circles. I could also do another line on the bottom the same type of way. Oh, that one not very good on there. I'll try to get it about right there. Anywhere else I could draw a line of tangency? Well, let's see. I can maybe crisscross through something like, this would be harder to do, but something like that. Try to get about 1 point right there. And same thing, crisscrossing the other way. Something like this. The point of tangency, point of tangency. Boom. So this guy has about 4 lines. 4 lines of tan that have common tangents. What about my next situation here, the blue circles? Well, this time I don't have any crisscrossers, but I got the outsides, right? I could get one about like right here. Right, point of tangency, and I can get one about right there as well. Kind of missed it, but so you're pretty close. So that one's got 2 lines. What about this last situation? Well, if I draw a tangent line to my small circle, that was kind of off. A tangent line to my small circle. It goes through my big circle twice, so it doesn't have a common tangent to the small one, nor the big one. If I drew a tangent line to the big one, that's never going to touch the outside of my small circle. So this guy's got no common tangents down here. No common tangents. And this one had 2. Okay, so just basically if you can have a tangent through 2 circles that are in the same plane, we call them common tangents. And we have a theorem that goes with this, and it should make sense. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So basically, if I have a line that intersects the circle at 1 point, in this case at point T, if I draw a radius from S to T, the center, to the point of tangency, it has to make a perpendicular. Right there. So the line is only tangent if it makes a perpendicular to a radius from the center to the point of tangency. And that would work no matter where I would draw a line. So if I drew, let's say I drew a line up here, that was tangent at exactly 1 point about right there. If I drew a line to the center, from center to the point of tangency, it would make a right angle. So just know that. The only time a point is tangent is if it's perpendicular to a radius. So let's use that information. It says KL is the radius of circle K. Determine whether LM is tangent to circle K. Justify your answer. Let's look. LM. We want to see if this guy right here is a tangent. Well, in order to be tangent, it has to make a right angle with the radius. So it's got to make a right angle there. Well, let's think about this now. Well, what did I just draw myself? A right triangle, right? And for right triangles, what do we know has to work for right triangles? The Pythagorean theorem. A squared plus B squared equals C squared, where C is your hypotenuse. Well, look at this carefully. Do I know all 3 sides? Yeah, I know both legs, 20 and 21. What about the third side? I'm not given the whole side. All I'm given is this little piece 9 right here. Well, do I know what the rest of that part of the triangle is? Sure. What is that of your circle? That is the radius. So really that entire side of the triangle is 29, 20 plus 9. So now I can set up my Pythagorean theorem. I got 20 squared plus 21 squared equals 29 squared. Well, I just got to make sure it works. If it works, it's a right triangle. This goes back to a couple chapters ago. So plus 21 squared, 20 squared plus 21 squared is 841. And if I take 29 squared, I get 841. So it checks out to be a right triangle, which means it makes a right angle. So is LM tangent? Yes, it is. And I justified my answer by applying the Pythagorean theorem, right? If it wouldn't have been equal, then it wouldn't have made a right angle, and then we would know it's not tangent, even though it looks like it is. So just because it looks like it is, don't assume. Apply something that you know that would make it a right angle. Let's keep using that. It says in the figure, WE is tangent to circle D. So it says it is tangent. So now I know this makes a perpendicular with the radius. It's stating that it's tangent. Find the value of x. Well, if that's a right angle because of the tangency, I have a right triangle now. So I can use my Pythagorean theorem. Right? One leg plus the other leg squared equals the hypotenuse squared. Well, let's think about this. So I have basically DW is one of the legs, and I also have WE as one of the legs, and then I have DE as the hypotenuse. Well, I got some X's and some different things. So we got to set this up. So DW, if we take a look, that's X. So I'm going to go with X squared plus WE, which is 24, so 24 squared. And DE, which is what? X and 16 together. Well, it's not 16x, because 16x means 16 times x. It's x plus 16. So x plus 16, and I'm squaring it, so I got to square that whole side, right? C squared. So I got to square that whole side. So it's all about how you set this up. Well, be careful now. I think everybody's okay with doing the 24 squared, which is 576. So I got x squared plus 576. I see a lot of people make this mistake. They get going too fast and they don't really think about what this is. They want to just take x squared plus 16 squared. Can I do that? No, I cannot do that. That does not work. Think about what this means. This is x plus 16 times x plus 16. Well, that's our FOIL, right? X times x, and then x times 16, and 16 times x, and 16 times 6. It's going through that whole process. So I can either do that, I can write it out and go through the whole thing, right? I can take each thing term by term. Or if you remember, this makes a perfect square trinomial. So it's going back. What do? Well, I square the first term, x squared. I square the last term, so 16 squared. And how do I get the middle? I multiply these two. So 16 times x, which is 16x, and double it for 32x. So it's going back to algebra now. And if I would have went through this whole process, I would have got x squared plus 16x plus 16x plus 16 times 16, so 16 squared. And it gives me the same thing, right? So I'm just using one of my special products from last year in algebra. Well, let's simplify that 16 squared here. I get 256, so I'll replace that. 256. And now it's just our algebra. Well, let's get our x squareds on one side. So subtract x squared, subtract x squared. They basically just cancel each other. Okay, and let's get our x by itself. So I'm going to subtract 256, subtract 256. And so we're left with 320 equals 32x, because that's gone. Well, if I divide by 32, x has got to be 10. Is that what I'm solving for? That's all I need. X equals 10. Always go back and look. Yeah, that's what I'm looking for. So we're done. All right, so just be careful when you get that set up. My last theorem here, if two segments from the same exterior point are tangent to a circle, then they are congruent. So basically, if I have a point outside of the circle and I draw two different tangents to the circle. So I got one going from B to A line of tangency right here. And we'll just end it right at A. And from B to C, they have to be congruent. Okay, so if they're from the same exterior point and tangent to the same circle, then they are congruent. And they look like they should be. So let's use that here. It says the round cookies are marketed in a triangular package to pique the consumer's interest. That's right, kind of enhance their interest or intensify it. If triangle QRS is circumscribed about circle T, find the perimeter of QRS. So I need to know all this information. Well, let's take a look. So let's deal with this point S. That's point exterior. Looks like it's tangent to N, and it's also tangent to M, so I know these are congruent. So this also has to be 10 centimeters. Well, the same case from N to Q and Q to L here. So I know this guy's got to be 2 centimeters. Well, and these last two should be M to R and R to L. Right? They both go to the same. They're both tangent and go to point R. And can I figure out what those are? Well, yeah, this whole side right here is 8. And if I subtract 2 from 8, that leaves me with 6 centimeters for this piece. That means this also has to be 6 centimeters because they would be congruent. And then I can just add them up. So 10 and 10 make 20, 2 and 2 make 4, 6 and 6 make 12. And if I add all those together, 20 plus 4 plus 12, that would give me 36 centimeters for the perimeter. So just applying our last theorem. All right, that's all you need to know about your tangent lines.